Hi, welcome back to the series for deep learning. Today I'm going to explain the implementation of one that is called CNN. How we can recognize the digits using the CNN. Very simple method. Already explained in the another one. Today I'm going to say the second one. So whenever you want to continue to please check the playlist where we get continuations. So all of you know convolution neural network is one of the concept very familiar today. It's a extension of CNN. So we are going to use CNN for digits recognition. Whether you give 7, it will predict 7 like that. Or if you give 6, it will predict and print the digit like that. So this is the one. So what we are going to means is just we are going to import tensor as a TF. Then we are going to train the variables like x underscore train, y underscore train. These are and also test x underscore test, y underscore test training and testing with the help of keras. Then we are going to, so if we give this, what happened means in the Google Colab, download the data from the TensorFlow. Then I'm going to give the reshape. So x train is called x underscore train dot reshape, where shape of 0, 28, 28, 1, I'm giving the measurements. So later we get more thing and test. So if you go training of 80% data, where from that 80, if you have 100% data, where we can take training 80% for training and 20% for testing. That is possible. And I'm going to assign the type as a float 32 and test also as a float. Both should be similar. Then I'm going to give the digit number where x underscore train divided by is equal 25 followed by x test underscore 25. So whatever digits are, it had to predict it exactly. That reason I'm giving these values. And then I'm going to call the from tensorflow.keras.model import sequential and all the layers. As of you know, convolution layer is uh, CNN having the layers like convolutional, plot, max pooling, draw, say dense, and mainly to have convolution. That is the main one, pooling and so on. So I'm going to generate a model with the help of model is called sequential code. Then you go to add a conversion to 2D dimensional 28 comma kernel size. I'm measuring 3 comma 3 input underscore shapes called input shape and followed by the max pooling and flatten dense dropout dense. So as of you have idea about this, I hope that you idea about CNN. So here convolution layer is there, whatever the input is there, input image or input, whatever the input data, it will multiply by the kernel and move for the other step. So once go to max pooling, it reduces automatically the dimensionality problem. That means whatever the data, it reduces the dimensionality, then resolve it and flatten. So flatten just flatten the things like whatever the from one neuron to another passing, continuously flatten everything. Whatever the data, input image or data, it will flatten. The dense is there where it also forward everything properly and drop out. Where drop out to decide which layer have to which neuron to forward to another one, or else you have to drop out like that. Continuously is going on and at last you have dense and dense also with activation. So as of in activation means activation where we follow the ReLU function. It is for avoid the gradient vanish problems. Then I'm going to compile model.compile of optimize Adam loss and metrics accuracy and model.fit. I'm giving the plain value efforts about Q10. Once Q it may take based on internet speed. After generating, go for evaluate. How can I evaluate? I can use the code called model.evaluate of x underscore comma y underscore test. Then import MATLAB, import plot. Then at last I'm going to predict. How can I predict means I can use the code called image underscore index, that is 285 2854. So every image having some index where you can change the runtime 2852 or 2856 and so on. So as of you know, the everything taken for the MNIST data set. So lot of images there, and we can give the plot IM show at last predict the image with the help of or digit with the help of model.predict of x underscore test image underscore index reshape of 1 comma 28 comma 28 comma 1. At last we can print with the help of prediction dot argument. So this is a way how we can recognize the images with the digits with the help of CNN. Thank you for watching the video. Thank you.